All right, today guys, we're going to be talking about solving systems of linear equations by graphing. This is the last step in our functions unit where we're going to try to find the common solution for the equations of two different lines. Now, as you see in the text that's there in the corner, it says that identify and verify the values of x and y that simultaneously satisfy two linear equations in the form of y is equal to mx plus b from the intersections of the graphed equations. So let's go ahead and take a look at our next visual. So just to recap, again, an ordered pair that's x and y is going to be a solution of an equation in two variables if substituting the x and y values into the equation results in a true statement. Now, when we say a true statement, that means where each side of the equal sign will have the exact same thing. Now, a system of equations is going to be a set of equations that have the same variables, in this case x and y. An ordered pair is a solution of a system of equations if it is a solution for every equation in that set. So for instance, every point along this particular line is going to be a solution for that equation. Every point along this line is going to be a solution for that one. So that is something that's a bit new. We've never described an ordered pair as a solution, but that, in fact, is what it is. So if we look at this example, we see that in that first equation right here, it says y is equal to negative x plus 4. And the next equation is where it says y is equal to 3 times x. It says that we're going to start by graphing each equation. Now we know, because of the fact that y is equal to mx plus b, we know that this part of this equation is going to be our b value, or that's our y-intercept. So we would start here by plotting 4. We know that the slope is here. Now, you don't see a number, of course, but we assume that there is a 1 in front of that. Now, there's actually a negative, so we assume that that is a negative 1. If you remember, in the form of rise over run, and if you don't remember that, go back and look at our different depictions of slope. There's another video that talks about it. That is going to be a negative 1 over 1, meaning that your rise is negative 1. We would go down negative 1, and then we would go over to the right, which is going in the positive direction, 1. I'm going to talk more about that in a moment when we look at how we plot these lines. Now again, this is also in the form of y equals mx plus b, where m, your slope, is going to be 3. That's 3 as your rise, 1 as your run. We assume also, because of the fact that there is no value of b, meaning that b is equal to 0, that the first point that we would plot is at the origin. Now remember, a y-intercept of 0 will be your origin, okay? And then once we confirm graphically, when I say graphically, on this graph we see that we have an x value of 1, we have a y value of 3. So the point at which these two intersect is going to be your solution, as it says here, of a system of equations. So that value, and in this case 1, 3, as we have here, if I were to plug in a value of 3 for y, in this equation and this equation, and a value of 1 in this equation and this equation, they're both going to equal 3. So the solution, as it says here at the bottom, of the system is going to be 1, 3. Now, what we're going to do at this point, and now that I've given you a little bit of background, we're going to move over to actually solving two examples here. All right, so the first two equations that we're going to look at would be y is equal to negative x plus 2, and then y is equal to negative 4x minus 1. Okay, so I am going to go ahead and switch over to my actual coordinate planes that I have here that we're going to be working with and what I'm actually going to be writing. So give me a moment. Oh, great. So as we have here, we see that our TEKS number would be 8.9a, again, solving systems of equations graphically. Our first step, just to recap, is going to be where we graph the equations. And then we need to make sure that we graph to confirm our solution. Okay, So we confirm our solution. And then step number 2 is where we're going to confirm mathematically. And I'll show you what that looks like in just a moment. Okay? So we're going to graph the equation, make sure that the graph is used. Sorry, I forgot some words here. Is used to confirm our solution, and then confirm that our solution mathematically works. In both equations. Okay? So if we take a look here, we see in that example that y was equal to negative x plus 2, and then y was also equal to negative 4x minus 1. So when I graph both of these, I'm trying to see where my point of intersection is, because my point of intersection, as we know, is going to be the solution. So first things first, how do I know where to start? Okay, now I know where to start because of the fact that we know in the form of y equals mx plus b that b, or the number 2 in this particular case, is going to be my y-intercept. So that's where it hits the y-axis, right there. We also know that this slope in the form of rise over run, since this is a negative x, we assume a negative 1. Okay, so again, that will be a negative 1 over 1. Any number, as we know, can be made into a ratio or a fraction by putting it over 1. And let's go ahead and do this one right off the bat. We know that our slope here is going to be negative 4 over 1. Okay, so that's our slope, rise over run slope. All right, so I know that when I have a rise that is negative, that means that I'm going to go down 1. So I'm going to go down 1 here. And the number on the bottom is positive, so that means that I go to the right. So again, 1, 2. These are our 2 points to create that line. So what I'm going to do is I'm going to do my best to line these up along the grid line. If you see my head, sorry. All right. I'm going to draw this line here. That looks about right. Now, I'm going to go on to my next line. Now, again, remember the goal is to see where the lines intersect. Okay? So at this point, I want to also go ahead and plot my y-intercept. That's negative 1. I'm going to plot that there. Now, I also want to go ahead and plot my next point by using my slope. That's rise over run. That is going to be 1, 2, 3, 4 down. That's going to give me to 5. And I'm going to go over 1 here. So what I'm going to do is I'm now going to use these 2 points. And I'm going to try my best to line these up as best as I can. So what I'm doing is I'm looking for a point of intersection. Now my point of intersection is there. That point is negative 1, 3. So I am looking to see if my solution is negative 1, 3. So I've looked at it graphically. Now I want to confirm it mathematically. And I'm going to do that on this sheet. Okay? So we're going to confirm that mathematically. And I'm going to draw myself a line here just to keep everything separated. Okay? So now, I want to confirm it mathematically. So I'm going to put both of these equations here. That's negative x plus 2, and then y is equal to negative 4x minus 1. Sorry. Okay? So now, I'm going to plug this ordered pair. Now remember, we know that this ordered pair, those 2 equations that we started with, this is what we confirm graphically, and I want to see if in fact it works out mathematically. So remember that we can also call this, in addition to an ordered pair, we know that this is a solution of the systems of equations, or the system of equations. All right, so I'm going to plug in my y value there. I am going to plug in my x value. So why did I put a negative sign there? This is still a negative sign outside of this x value. So this x value goes inside, and I still need to put that negative sign there, and I'll show you why that's significant in a moment. Okay? I'm going to do the same thing over here. Negative 4 times a negative 1 minus 1. Okay, so again, based on the distributive property, we know that we imagine this to be an imaginary 1. When I use the distributive property, that means that I am multiplying what's on the outside times what's on the inside. Negative 1 times a negative 1 is going to give me a positive 1 plus 2. Sorry, I'm switching around like this. All right, so 3 is equal to 3. Is that true? So far, so good. Now, let's look here. 3 is equal to negative 4 times negative 1 is positive 4 minus 1. So 3 is equal to 3. Is that true? We have a solution for those two equations. It satisfies both of those equations. This is my point of intersection that is solving for the systems of equations. Sorry. All right. So now we're going to do the exact same thing for the next one. So let's go ahead and go back to that initial slide. So taking a look back at our equations, we have a y is equal to negative 2x plus 5 and y is equal to 3x. What I want to do is I want to graphically confirm, that means on the graph, whether what my solution would be, and then confirm that mathematically. So let's go ahead and move back over to our work. All right, so I'm going to move this off to the side for now. I'm going to use the exact same principles that I did before, where I'm going to look y equals mx plus b is your format for the equation of a line. Starting here, I'm going to use this value as my b because it matches up. Notice, okay, so 5 will be that first value. And then I'm going to use my slope here in the format of rise over run. This is a negative 2, therefore it's a negative 2 over 1. Doing the same thing for that one. I know that my slope is 3. So in the form of rise over run, that is equal to 3 over 1. Now if you notice here, there is no additional value. When that is like that, we assume that that is 0, because this formula shows that there is direct variation. There's no 0 here, but we know that 0 means the origin. That's this point right here in the middle of the coordinate plane. But let's go back up here to this equation. So I know that my rise over run is going to be negative 2 over 1. That means I go down 2. That's 1, 2. And go over positive 1. If it was going to be negative, I would go that way, but it's not. Okay? So this would be my first 2 points. I'm going to go ahead and connect these. I'm going to try my hardest to make sure that it's perfect. Okay? Now, let's go ahead and use the rise over run. In this particular case, remember I'm starting at my origin. That's there because this is 0 in that format, okay, or in this format. Now, my slope is going to be a rise of 3, and I'm going to go over my run of 1. 1, 2, 3, and then 1. If you notice, this point is already denoted. So what I'm going to do is I'm going to connect these two. I'm going to connect these two. So right now we show that our solution should be 1, 3. So I'm going to go over and try to confirm that mathematically that my solution is 1, 3. Okay? So do we see how that works? The point of intersection is going to be your solution for your systems of equations. So let me go ahead and confirm that mathematically. I know that my formula, my first formula was y is equal to negative 2x plus 5. Through the magic of YouTube, what I've done is I've sped that process up. As we see, negative 2 times 1, when I plug that in, is going to give me negative 2 plus 5. And when I simplify this, 3 is equal to 3. 3 is equal to 3. So therefore, we have a solution for those two equations. The point of intersection is going to be my solution. Now, as always, if you have any additional questions, please back up this video, watch it again. If you don't get anything from that, please come to tutorials or ask me a question in class. And as always, I will see you tomorrow.